Good afternoon everyone and welcome back to Man and Machine's Virtual Summit for 2023. For those of you who don't know, my name is James Dack. I'm a Senior Business Development Manager here at Man and Machine. And firstly, I would like to thank Peter and Cameron for their very insightful session on Inventor and all the latest developments. Our next session today is going to be all around the topic of simulation, looking at the Nastran FEA tool. For a lot of my clients, the Nastran FEA tool and simulation in general can be a very powerful additive to their sort of production portfolio. The reason being is that a lot of tests are pass or fail and cost thousands of pounds. So to have that extra validity of their products, know that it will go to the test and pass, is going to be extremely useful for those clients. And on that note, I'm joined today by my far more knowledgeable colleague, Chris England, who's an application engineer. He's going to go through all of the latest updates and changes regarding the software, and hopefully you'll find this session enjoyable and useful. Please feel free to write any of your queries and questions in the chat and we'll get back to you as soon as we can. Thank you very much. Over to you, Chris.
Thank you, James. So I'll be presenting Nastran What's New 2024, and we'll be showing some of the new features that have come out in the latest edition. And we're going to jump right into it because I don't do the sales talk. I'm here for the technical, so we're going to jump into the product now. And we're going to start off 2024 by looking at 2023. It's not often that I get a chance to show one of the background updates and something like an algorithm update or the functionality of the product and how it actually works in the background. And fortunately for me, last week I actually picked up this part. I was sitting with a client and we managed to prove the new mesh algorithm and how that has come about and some of the enhancements, or at least focus on one of them. So looking at 2023 quickly, I don't want to spend too much time here. But if I just go to mesh settings and I try to generate the mesh on this part, it's just a sheet metal part. It was given to me by the client in question. I've said I wouldn't mention them, but you guys know who you are, and thank you for the model sponsor. And we can see that the mesh hasn't generated. Now, I'm not saying that we couldn't get it to generate in 23 because I did in the end, and there are ways we can. But just on a direct comparison, if I jump straight to 2024, I can then, I'll just get rid of that quickly. I can then go and generate the mesh here, and we can see that it's able to generate the mesh on that part straight away. So, you know, I'm not saying that it is part of that algorithm update. It's just, it was quite interesting that it failed on 23 and I thought to open it in 24 and it worked. So there's some of the mesh improvements. So that's one of the features that has come about in 2024, is that they've improved the algorithms for the meshing. So I'm going to go ahead and run the simulation on this product as I've got it open, and we'll see what other features come along. Now, when it came to this part, because it's a thin body by nature, or at least it's got a consistent thickness throughout being sheet metal, it was actually a better option to go and create thin bodies out of it. So even though I generated my mesh painstakingly, I'm going to go ahead and change my body, which means that the mesh will need to be regenerated anyway. So we go to thin bodies there, and I'm going to go, we're just doing a simple test. These outward outcroppings, these outcroppings on the side to support their shelves, to support our load. So we have some UPSs and batteries that sit on these shelves. It is part of a much larger structure, and obviously has framework and all the rest going about it. But we just wanted to test that these sheet metal folds would not fail underneath the stress. So I'm going to start setting it up by adding constraints at the bottom, and we'll choose the normal fully fixed constraints. And I'm struggling to see on the screen. I see why Cameron was leaning forward so much, so bear with me while I find the edges, and we're just selecting all these edges down here, and that's going to be our fixed constraints. Next, we're going to go and add our loads to the shelves. Clicking all the wrong buttons at all the wrong times. So here we go, adding our loads, and we're going to go for a force in the y direction, or at least in the negative y direction, and it was, for the first three shelves we have 60 kilograms, so we're going to say negative 300 newtons, and I'm just going with a simple factor of 10 for my gravity. Oops. And so here we go with our 3, and I'm not ticking the total force so that it's applying the 30 or 300 newtons rather to each shelf at this stage. And I'll go ahead and add another load And we'll go in the negative y again. This one is only 45 kilograms, so we'll go 225 newtons and apply it to the top shelf. So there we go, that's our loads applied. We've got constraints, so we'll go ahead and mesh this model, which it will mesh now as well in this thin body. And by the way, that was the solution for 2023 if you're looking into such things. So it's not like it couldn't be done on 2023, it just was easier and smoother in 2024. So I've generated a mesh. I'm just going with the default element size, and what we're going to do is we're going to go and refine the mesh on those shelves. So I'm going to go to my local mesh control. I'm going to choose the face data and just select the faces in question. And what I should be doing is getting the little bends where the sheet's been folded. So if I select all of those faces, and we'll just reduce it by roughly half the size, and I go OK. So I just missed one of my features. So within the local mesh control, we now have the ability to generate the mesh, but I can't select it now as I've already hit the OK, and I've ruined my whole punchline here. But anyway, there is now a generate mesh button within the local control, so you don't have to hit OK and generate outside. I guess the old habit's embedded in me, and I just went for it. So regenerating my mesh, and we can now go, oh, I didn't check my idealizations. Let's just double check that we're on the right surface. Where's the right click on this? There we go. And we're on mild steel. I'm just going to double check that it is the Nastran mild steel that we're on, or at least one from the Nastran library. So I'll just hit steel here and find mild steel. Okay, good. Got all my material properties in now, and I can go ahead and regenerate my mesh. Seems that's the theme here. So once that's gone, we'll go ahead and we'll simulate our results and just check whether the structure was, at least the sheet metal folds were going to fail. I think even if it was below or beyond its yield point in the material, we would be okay when we added the rest of the supporting structures, but we wanted to make sure that the thickness of plate was okay for this particular job. So I'm just going to jump to the safety factors. It's always the easiest way to check whether we've gone beyond yield, and we're at, although it looks rather overboard being deformed, it's actually not too bad, and our minimum safety factor is currently sitting at 3, which is just fine for this particular model and the job. So there we go, some of the mesh enhancements in 2024. Don't forget that the local mesh has the button to regenerate, which is what I missed out on. So moving over to the next model and having a look here. So I've got a billet press set up here. It's one of the tutorial exercises, to be honest, but one of the features that have changed in 2024 is the Explicit Quasi-Static Analysis. And it is quite a mouthful, so if I do get tongue-tied at some point, I do apologize. It's bound to happen. Anyway, with this setup, what they've changed here is in our Explicit Quasi-Static Analysis setup, in the options, firstly, we have a heartbeat here still, which was always there before, but we would have had the option for steps in the setup before, which has now been removed. And the reason it's been removed is that in our load setup, if I go ahead have a look at my load setup, I've just got a enforced motion here with a magnitude of -1.6 in my y direction, so we're just pushing this top plate down by 1.6 millimeters. And if I go look at the transient table, just the table, we can see that in this drop down I've already got it set up. The reason being is that one of these analyses can take up to 20 minutes or so to run, so I'm not going to run it for you. But we have load scale factor versus step. In the past that would have been versus time, so it's now versus step, which makes it a lot easier to measure our load factor versus where we are within the analysis. So looking at my setup, I've just got 2 steps, one step which starts from 0, and we start with this load scale factor of 0 there and going to the full load scale factor by the end of step 1. So it's going to gradually add our load, which in this case is an enforced motion. So throughout the step, it is moving down 1.6 millimeters. And if I haven't hit OK on any of my menus, we should be able to just get the results from before, which we have. So if I go and show those, we can see what that actually looks like. And I'm going to animate it. It didn't work through TeamViewer last I tried this. We're going to give it a go. Who knows? Caution to the wind. There we go. So we can see that as it's running through the step, the force and the stress, the von Mises stress, picks up, going right through until it gets to the maximum, or I suppose the minimum point that the plate is moving. So that's our quasi-static analysis. Just going to drop my results for a second to mention some of the things, as this is the only assembly I have available at this point. So some of the other enhancements that we have, go away. Cool. So is with the mesh. So normally our mesh color would be assigned by the idealization. So you can see that I've got a copper, alloy steel, and a non-rigid alloy steel for this particular setup. But we can see that because there's 3 different solid bodies in my idealizations, all assigned their own color, I've got 3 different color meshes. So one of the new options that have come in is in our default settings, we can go and change our display options and actually drive our mesh color. Now, this changes it across all bodies. So if you just wanted one consistent mesh color, you have it there. Whereas before, if you had wanted to achieve that, you would have had to go and set each idealization to its own individual color. Now we can do it all with one global setting. Of course, it does persist. So if you either have it on or off, really. You can change the color though. So it's a nice little function that's been added. I'm going to turn it off. I actually prefer the old way. So there we go. Another one that's been added is if I click the idealizations drop down, we now have the option here for a concentrated mass. Now I don't need a concentrated mass in this particular analysis that I'm running, and it's already run and we've already gone through the results, so we don't need to do anything to it, but just to add one or just to have a look at the menu. So concentrated masses, a lot of people probably wouldn't have used it, and the reason that you probably haven't used it is of potentially how hard it was to add one in the past. So if I go have a look, the only way to add one that I found beforehand was to expand our model and find, and I'm going to have to spot it on the screen, there we go, our concentrated masses over there, and add a new one. And then once you've got a concentrated mass within your analysis, it would then appear there and you can add it from there. But that was the only way I found, or I knew of before, and that's how I would have added one in the past. So very nice little addition, small things, but they do add up and they make a nice difference to the overall finish of the product. Okay, so I don't have a time. I don't know how my time's running.
Okay.
I'm good?
Yeah, okay.
I'm good with time. So let's carry on. So another one of the features, and I've stolen this model from one of the data sets written by Wasim Yunus for the FEA FEA training, the normal Inventor FEA training. And so I appreciate the model. And looking at it, we've got a fan, and this would be a rotational force that we'd apply to it. And I guess in normal settings, we would look at a worst case scenario where we have a seizure of some sort or another, and that force is then stopped, and we then see what the result would be. Now, I've set this one up, I suppose, in a more traditional way, and gotten some results. And the reason I'm rambling on about this particular model is one of the new features is the ability to add cyclic symmetry. So if I go and have a look in my normal linear static analysis settings, if I go to options, you'll see that we've got the ability to add cyclic symmetry data and tick on the cyclic symmetry box, which then just requires a coordinate system. So quickly talking about coordinate systems beforehand, because it might not be something that you've used in Nastran before. We do need a single coordinate system used across the board, and of course in a model like this we would want it in the dead center of our fan, or it's called the fan, so I'll name it the fan. So our fan component, right in the center we want a coordinate system. Now you can either create a coordinate system by right clicking and new and create one manually, or it can be created in creation of your pin constraint. And frictionless also add their own coordinate systems to them. So if I go and click on pin constraint, there are some new features here too that I want to show off. So within it's not changed the functionality of the pin constraint. It still works functionally the same. Just when you're in the pin constraint option, or you've clicked the pin constraint type from the top drop down, it now changes, and I'm struggling to see my buttons, but the buttons now reference cyclic geometry rather than the normal X, Y, and Z and rotation about X, Y, and Z. So translation X, Y, and Z. It's now theta, radial, and axial, if I'm not mistaken. I think it's theta. So it now reflects, I suppose, proper cyclic referencing, which is quite nice. I'm not going to set this up as it's already set up, as you can see. We'll just have a quick look at the results, because then I'll jump over and explain where the cyclic symmetry comes in handy. So let me just load the results and bring them up again. They were there. Okay. So we can see I've not overly strained this particular model. I just want to have it from a comparison point of view. So we've obviously done this on the full model. And just having a quick look at my... Nope, it's gone. So I wanted to look at my Nastran output file, or log rather, to see the number of warnings that we get. Any user of Nastran would be quite used to the warnings that we get. Of course, warnings aren't too bad as long as we know what they are. Errors are the problem at the end of the day. But with the warnings, I think, I'm going to go in memory here, so I think I had about 1,000 warnings on this particular model. Most of them, or in fact all of them, were just to do with the minimum and maximum angle settings within our mesh. So to explain where that comes from quickly, 3-button mouse. So it comes from our settings within our mesh, and we've got the minimum triangle angle and the maximum triangle angle. So basically, if our mesh angles, or the tetrahedron angles, don't fall within that scope, we would get a warning for each time it happens. So 1,000 warnings means it's happened 1,000 times, it's breached that minimum and maximum angle. Now, when working with that, the other thing, or when working with any geometry in Nastran, is always going to come down to simplification, and FEA in general, not necessarily just Nastran. So when it comes down to simplification, we always try and simplify a model on a symmetry axis, or a symmetry point, or plane rather. And if I quickly have a look at what I've got set up here, we can rerun this one, so it's fine. If I drop it, I've changed my model state to be a single blade. So basically I've cut it. There are 12 blades, if I counted correctly earlier, on our fan. And if you slice it in an equal fashion, and then it could be patterned, I guess, cyclically, we could then set on our options to cyclic symmetry, choose our symmetry coordinate system, which I set up in the previous one with that pin constraint. So we've got one right in the middle, and you can then add a tolerance for your cyclic symmetry. Now, what that allows us to do is, as you can see on my model here, is with it being simplified, we have 9,800 nodes versus 1,000. So we've reduced it massively. And the other thing is, if I go and run it, I'll have to run it to get the output. It shouldn't take too long, hopefully, through the team viewer session. Not too bad. And the text is very small. Hopefully it's bigger on yours, but I think we've got about 400. So I probably had more than 1,000 on the previous one, but I think it's 400. So it definitely reduced the number of warnings that we have then. Of course, I could refine the mesh and all the other tricks of the trade to get it to a lesser point. And it looks like my my frictionless constraints have not done their job, as the force magnitude has changed. Nonetheless, the point being that we now have this cyclic symmetry option available, which enhances or allows us to simplify models from a cylindrical point of view. And in general, simplified models mean a better user experience. So quite happy with that one. And that concludes my What's New features for 2024.